In this video I'm going to show you how to find the determinant of a matrix. We're going to look at 2 by 2 matrices and 3 by 3 matrices. We'll start with a 2 by 2 matrix, which is far simpler to find a determinant of. And by 2 by 2 simply means a matrix that's got 2 rows and 2 columns. And to find the determinant, there's 2 different ways to do it. You can look at it and do a kind of cross multiplication thing, or you can memorize a formula. So if we look at the cross multiplying, you do a times d, this diagonal, and then you subtract the other diagonal. So a times d minus b times c. And if you were to write this as a formula, you would get AD minus BC. So the determinant of A is AD minus BC. So you can either just look at it and do this, or memorize this with this matrix and substitute in the numbers, and that will give you the determinant of A. So we'll do an example. So we'll find the determinant of matrix B, where B is 5, 2, minus 3, 4. So that's A, B, C, D. So to find the determinant, we can do the cross multiplication, 5 times 4, and then subtract 2 times minus 3. You have to watch out, there's 2 minus signs. So we can either substitute this in to this equation or do this way. So substituting into there, you got AD 4 times 5 minus 2 times minus 3. And you put that together and it will give you 26. So we'll look at a 3 by 3 matrix, which is a bit more complicated to work out. So there's 2 ways to do it. You can do a sort of cross product. If you know how to do a cross product, this will be very simple to do. Or the slightly more difficult way is to use cofactors. This is a big 3 by 3 matrix here, and it's possible to split this huge matrix up into a series of smaller matrices and find determinant of 2 by 2 matrices. And the way this is split up is by covering up bits like that. It's usually done with pencils, and you would move this vertical along by 1, and it will give you all these terms. You see how this intersects at A, those 2 lines. So you get A, and it leaves behind this matrix here, EFHI, which is that there. When you move that vertical line along 1, what you're left with will be this, and they'll intersect at B. You move that along to the end, so it's covering that column there. You'll be left with this. And you ought to remember this minus sign. It's minus B. You just memorize that there should be a minus in the middle there. The other way is to use a kind of cross product, which I think is far simpler. This is the way that I usually use. And if you know how to find a cross product, this is obvious, but basically you just multiply each of the diagonals. So you've written out the matrix twice, and you multiply starting at the top of the first matrix, multiply all of the diagonals across like that. So A times E times I plus B times F plus G times G, and then you do it in the opposite direction and you subtract these. See, these are starting at the top of the second matrix and just going diagonally in the opposite direction and subtracting those. And if you were to manipulate all of the algebra on these two formulae, you would get this expression here. So in theory you could just plug your numbers in and it would give you the correct answer, but you're better just learning one of these 2 methods. We'll start with the cross-product method, which I find far simpler, and we'll do an example. We'll find the determinant of this matrix, and the way to do it is write this matrix out twice, like so, and then do the cross multiplication, well, the cross product, by multiplying the diagonals, as so. Just do all those multiplications and add them all up, and then do it in the opposite direction and subtract each of these, being very careful with the negative signs. And you do all that, you get this expression here, and simplify that out and you get 7. You see, like this one here is 2 times 2 times 1, which is that. If you look here, this will be the end term there, which is 1 times 2 times minus 1, which is there, and you're subtracting that. This all gives you 7. The cofactors, so I find this matrix using the other method. So we draw the two lines, or you use two pencils, and they intersect at 2, and you're left with this matrix here, because all of these are covered up. So that gives you this. So I find the determinant of this matrix and multiply it by where the two lines intersect. And now if we move those vertical lines along, the vertical line rather, along one, it'll intersect at 3, and you're left with this matrix here. Now remember, it's minus b when we had an ABC at the top. It's minus the second one. Find this determinant. And move along 1, intersects at 1, and we're left with this matrix here, which gives this. So we find each of these determinants using the determinant of A is AD minus BC, or multiplying across the diagonals. You're left with this expression. You see in this first one here we've got 2 times, and then 2 times 1 minus 2 times minus 1, which gives you this here. This is minus, and 3 times the determinant of this is minus 4 times 1 minus 1 times minus 1, which gives you that. And you do the same for this here. When you simplify all that out, it gives you 7, exactly the same as the previous method. Another thing that's just worth remembering, because it will come in use later, is the idea of singularity. And that simply means that the determinant equals 0, and the matrix has no inverse in this case. It's very useful in later linear algebra that you may have to do.